Hi everyone, welcome back to my channel. Today we're going to learn about what is an agent. Agent is a body that can make decisions on its own. It's based off the word called agency. So agency lies where something understands the situation, decides what's the next step is, and then performs an action. That's the whole fundamental principle of AI agents. When we have to talk about one single agent, what does it exactly do? It perceives the environment or the query that the user gives, then it reasons what it's supposed to do next. That is the important thinking aspect of an agent. Then it acts autonomously, that it does not need a human to make its decisions. It makes its own decisions and move forward. And then it evaluates whether the decision that was taken is appropriate or not, whether a goal is achieved, or it needs to go back and perform the same action again. So it basically runs in a loop. This agent has access to multiple tools. Say if I have a retrieval agent and if I have a web search agent, it can access the tools. It can have memory. It can store what it initially did to understand what it's supposed to do next. And this agent can be the brain of this agent can be an LLM, or it can be any rule-based system or an ML model. Based on the complexity of the task that needs to be performed, we can choose what exactly drives this agent. So when we talk about multi-agent systems where we have multiple agents running simultaneously, how do we differentiate that? When does an agentic system become multi-agent? That's when we need to understand what each agent is doing. Are they working simultaneously parallel with each other, or is it one sequential flow where we have multiple nodes in the system that trigger the next node, and then that is called a multi-agent system? So for us to understand this, a key word here is coordinate. These autonomous agents coordinate with one another, see what the other agent is doing, and then perform their action. That's what makes it truly multi-agent. So we need independent decision makers, plus communication between them to understand what really is happening in between, and then distributed problem solving, that they have a common goal, that all of them work together to solve that. So to check if the system is really multi-agent or not, I recently posted a video about LangGraph multi-agent system where I had 5 nodes. Each of them was doing a different, they were serving different purpose. One was doing intent classification to understand what really the user wants to ask the system. Next was the tool call, that is relevant tools would be called based on the intent that was given. And after the tool call was done, whatever output is given, that would be evaluated to check whether that context is enough to respond, or does it need more information, so it'll go back and do the tool call again, or it needs to escalate to a human. And then later it had to escalate or respond. This loop would go on for 3 times. And after that, it had to respond and there was no retry again. So whatever information it had at that point in time, that is supposed to be used to answer. So here, what is actually happening? There are 5 nodes, and each of them is triggered once the previous one is triggered. That makes it a sequential workflow. So output of one becomes the input of another, in simple terms, or action of one becomes something that the next agent would evaluate and then take another decision. So this would essentially be not called as multi-agent, that would be a sequential workflow. Whereas in actual multi-agent systems, where we have multiple agents working together, they would run in parallel and they would have some sort of logic or a node or edge that is clearly defined to make them understand when they're supposed to communicate, when they need to check whether the goal is achieved or not, or what is the next or best step that they have to take. So just to quickly summarize that, multi-agent system only makes sense when it exceeds a single context window of one particular agent. So these subtasks are very easy to accomplish, that can be done parallelly. So output of one does not affect the output of another unless there is a node that does the checking here. And the value of the task justifies the additional cost and the complexity that multi-agents actually give. Says, for example, my Anthropic's research system uses multiple agents that run in parallel to fetch a certain information that we asked to do. Say a deep research agent, the whole research topic itself is divided into multiple subtopics, and for each subtopic there's another agent working on it, trying to find the relevant information regarding that. And then towards the end, all of the information is then combined and ranked and presented in a way that is best for the user to see. That's an example for a true multi-agent system. Where it does not make sense is agents are sharing same context, where the tasks are dependent on each other, and there are multiple conflicts. So we don't want conflicts. In that case, we would avoid. So for agentic, truly agentic system, there can be two patterns. One is a sequential flow, where there's a step-by-step procedure, what would come first, which agent has to start first, which agent triggers the next agent. So that would be clearly defined. Another pattern would be supervisor pattern. There would be one orchestrator that decomposes the task, like makes it into smaller steps, and then each step would be given to a different sub-agent, and then collects the output, and then you get a final answer. That's a true multi-agent system. When we are trying to put this in production, we need to first do evals on each and every agent. Suppose if we have 4 sub-agents, every agent needs to be evaluated on all the metrics that it does. Say if I'm doing a retrieval agent, I would really evaluate that with my Coldo data set, with its or how the quality of the retrieval, how well the context is being utilized, how is it faithful, and how correct is the answer. So every agent and everything needs to be evaluated. We would do certified eval to do across multiple categories and multiple difficulty levels. Observability, that is non-negotiable. Trying to have, when we're trying to rebuild what really happened in a particular case, we need to see what happened. What did the agent do? We wouldn't get to know what really the agent did by just the user answer. We need to see what path it followed, what are the steps it took, what decisions it made, how did it make the decision, what really happened. So at every point, at every stage in the agentic system, we would have to have traceability, like having traces written down somewhere. Say in case of LangFuse, we would write a function that would log a certain case. So continuous logging and very meticulous logging is essential. So that's important. Next is context engineering. When we are trying to have multiple agents, it's important for us to keep the context clean. We very often see context rot, where we give a lot of information to the system thinking that it would know everything, which isn't the case most of the time. It can get lost in between. So for us to properly define what is the right context given to which agent, so that we reduce the hallucination and how well it works, that is very important. So first, I think simple approach would be to build something that is sequential first if you're trying to make an agent. And then we decide when the next agent would come. So what purpose has solved, or how important it is, or what is the decision. It's not just an engineering decision then, it becomes a product decision. So that's about multi-agent systems. Thank you very much for watching. Thank you. Bye.